Well, class, we're on our new unit, which is fractions, something I'm sure you guys all remember and love from your previous grades. So let's dive right in. Remember, this unit, we're working on equivalent fractions and remembering what equivalent fractions are from back in 3rd grade. So just a quick reminder, if I have, let me turn my pen on. If I have a candy bar like this and I break it in half, and I give half to you, and I eat half, we both have some chocolate in our stomachs. Now, let's say you did not want a giant half like this, and you instead said, well, Mr. Wembley, since you're giving away free chocolate, I think I would much rather have this. I'd much rather have it broken up into 2 pieces. So now you get 2/4 instead of the regular what? Instead of the regular 1/2. But notice by looking at those pictures, they're still the same amount. So we haven't changed the amount you get. So that's what this whole lesson is about, showing about how 1/2 is the same as 2/4. Remember, with fractions, it's parts over wholes. And that parts is how many pieces you have shaded. So this red one, I'd have 2 pieces shaded up here. And the whole is how many total pieces there are. You'll notice there's 1, 2, 3, 4 total pieces. So that's all we have for fractions. If you can understand fractions are parts over wholes, you've done an excellent job and you're ready to actually move on to 5th grade, believe it or not. But it's that understand that's difficult. So this first one right here, question number 1 says, use the Airy model to explain why 3/4 and 9/12 are the same. So let's begin. My pen's charged right now, so I'm going to be writing in my hand, which obviously isn't the best. So how do we know these two are the same? Well, when the rectangle is divided into fourths, and notice that fourths is shown by those solid black lines. They're shown right here. This is when I broke it up into fourths. There's 1 piece, 2 piece, 3 piece, and 4 piece. So that's what it's talking about when we say we broke it up into fourths. So when we break it up into fourths, the shaded part shows 3/4. And how do you know it's 3/4? Well, there's 1, 2, 3 parts that are shaded, but there's 4 total parts. So we have 3 shaded out of 4. Remember, it's parts over whole. And so now, oops, not a comma, now we need a period. So now we have this phrase, when the rectangle is divided, or when it's divided, into what? Into 12ths, the shaded part shows 9/12. But notice how we didn't change the amount of shadedness. We didn't go and add more of that orange color. It's still the exact same amount of orange. It's just been broken up into more rectangles. So let's head on to number 2. Are 4/5 and 4/10 equivalent expressions? Explain. Well, our answer is no. And instead of doing a model with this, I want you guys to think about it. If I have 4/5, that means it's almost a whole. It means we're just 1 piece away from a whole. Whereas if we have 4/10, that's really close to a half. So is 1 whole the same as a half? No. So we're going to use that reasoning to record our answer because it says that explain part. 4/5 is almost 1, or we could say 1 whole, and 4/10 is almost 1/2. And as we obviously know, 1/2 is not the same as 1 whole. So let's head to number 3 now. It says, write a fraction equivalent to 2/3. Well, if we know our fractions well, we could do it without drawing. But since we're just getting started with it again, I'm going to draw a picture. And I have 2/3 here, so I'm going to shade 2 parts in. And notice there's 1 part left over. And now, how we make equivalent fractions is kind of easy. We just split it the opposite way. So we drew what's called vertical lines. So to make our equivalent fraction, we can just split it horizontally. Oh, and now look, there's 1, 2, 3, 4 pieces. So there's 4 pieces that are shaded out of how many? Out of 5, 6. There's 6 total pieces. So there's an equivalent fraction to 2/3. Now let's do the same thing with this 6/8. So again, since I'm just starting out, I'm going to draw it with my horizontal. I need 8 total pieces. So 1, 2, 3, 4, 5, 6, 7, and 8. Now, to be absolutely correct, they do need to be the same size. Notice how this little guy right here is much smaller than that. So they should be the same, but again, since I'm with my fingers, it's not the easiest. And now I need to shade in 6 pieces because it tells us we have 6 parts. So that would be 1, 2, 3, 4, 5, 6. So, there we go. Now, we have 2 ways we can do this. Like our last one, we can split it in half and see how many shaded parts we have. That'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 shaded out of how many total? Out of 12, 13, 14, 15, 16. So there's one that's the same. Now, what we are going to work on later is we're going to work on something called simplifying or reducing fractions, which means I can actually find equivalent fraction that's the same size but with smaller numbers. So 3/4 is also equivalent to 12/16, which is the same as 6/8. If you don't believe me, draw a picture and you'll find out. So now number 5, it says find the missing number, and what's nice is they give us this map over here. So here is 1, here is 2 for that 2 shaded part. So now when they broke it up, notice we have 1, 2, 3, 4 shaded parts. Out of how many? 8, because there's 5, 6, 7, 8 parts. So same thing with number 6. 1/3. Well, here it's nice. They show us that 1/3. And then instead of breaking it apart like this, they broke it apart by splitting them all in half this way. But notice when they split in half, they're still equal sizes. This size is the same as this size. So now how many shaded parts do we have? We have 1, 2 shaded parts. Out of how many total? Well, 1, 2, 3, 4, 5, 6 total parts. So now that we have that concept down, let's head on to number 7. Write a fraction equivalent to 1/5. Well, again, this 1/5 they show us is this shaded part right here, and then they split it in half. So how many parts do we have when they split in half? We have 1, 2 parts. So that is going to be 2 parts out of my total. Because remember, it's always parts over whole. How many pieces do we need to make a whole? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 pieces to make that whole. Number 8, let's see what we have here. It says write 2 fractions equivalent to 4/12. Now notice this one's a little bit different because it has a circle in it. And I'll tell you, since it doesn't say to use the model, I'm going to instead use a fraction strip, just because I think that's easier. Otherwise, you have to draw it like this, and then it just gets a little hard for me. So 4/12 means I have 12 total pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And how many do we have shaded? Well, we have 4 shaded. So we have 1, 2, 3, 4. So what can we do? Well, first we can split it in half. Whoa, I had my highlighter on. Can split it like that. So now we'd have 1, 2, 3, 4, 5, 6, 7, 8. So I would have 8 pieces out of how many? 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So that's one way we can do it. Now, if we wanted to split it again, we could split it like this. And even though these aren't the same size, because see how that part's bigger than that part? If we just pretend they're the same size, it would also work. Or if it really bothers you, we can redraw the whole thing. But it honestly doesn't bother me that much. So as long as I remember they're supposed to be the same size, I'm okay to go. So then what would I have? I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So do we notice something that we maybe missed there? Yeah, if you noticed it, this was 24 right here, and we forgot to add these 12 on that were already shaded. Because remember, it's parts over whole, not parts over unshaded. So what's 24 plus 12? Well, that's 36. Now, maybe you guys have noticed a pattern so far. If you have, look at this. 4 12ths, 8 24ths, 12 16ths, or 12 36. Notice this is times 2, and then times 2, and this is times 3, and notice we did the exact same thing up top was times 3. So when we're finding equivalent fractions, what we're really doing is we're multiplying that numerator, that top number, and the denominator by the same number. So if we multiply a numerator by 3, we can multiply a denominator by 3, and it gets us that same number. But that's going to be a future lesson. Just if you noticed already, excellent job. Now for this one, it says draw an Airy model or use fraction strips to solve each problem. So here I have 2 8s. So I need to break it up into 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. Let me check one more time. 1, 2, 3, 4, 5, 6, 7, 8. Oops. And I had a little too many. Okay. And we have 2 parts shaded out of 8. Now, since we're going to a smaller number, it doesn't really help us to break it like this and make it bigger. So I'm going to have to think, does this look like any other model that I have? And if I have my fraction strips out, I would notice that it's going to look the same as this. And what fraction is that? Well, that's 1/4. We have 1 part shaded, and there's 4 total. And just to check, I could break it in half, and then I look and I see I have 2 parts shaded, and there's 8 total pieces. Now this one, you may have noticed, instead of going to a bigger number by multiplying, it's the same as if we divided it. 2 divided by 2 equals 1, and 8 divided by 2 equals 4. So now let's head off to number 10. So number 10, we have this area model. So we have 2/4. So 2 parts are shaded in out of 4, and we need to make this bottom number 8. So if we split it in half like this, notice how there's 8 parts here. So how many shaded do we have? We have 1, 2, 3. We have 4 shaded parts. Let's head to number 11. 11, we have 1/2, probably the easiest fraction to draw, and we need to break it up into 6 total pieces. Right now we have 2. So if we split up like this, we have 4 total pieces. If we split up again, we have 6 total pieces. And now how many shaded parts do we have? We have 1, 2, we have 3 shaded parts. Heading off to number 12, we have 3 shaded parts. And we need to make it so there's 6 shaded parts, which split it like here, and now we have 1, 2, 3, 4, 5, 6. And maybe you noticed, this is also the same as a whole. Now let's go off to this one down here. We have 10 pieces, so we have 1, 2, 3, 4, and 5. And then I'm going to split it like this, just because it's easier than keep drawing them like that. But notice, it's still 10 pieces. But our tricky part is, it needs to be 1/5 that we start with. So let me draw 1/5 right here. And I shade 1 in. What do I notice about this? Well, since this whole section's shaded, that means this whole section would also be shaded. It's the same thing as if we split up like this. And now we see we have 1, 2 pieces, 1, 2 pieces. Okay, heading off to number 14. We have 5, 6 here. So we need to have 6 pieces, 1, 2, 3, 4, 5. And this last one looks like it's going to be a little big, so I'm just going to shorten it. 6 pieces, and we have 5 shaded in. So that's 1, 2, 3, 4, 5. And now notice, we need to have 10 total shaded pieces. So remember, if I split it in half, I now have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we're looking for the total pieces now, the whole amount. So how many total pieces do I need? Well, I would need 11, 12. I would need 12 total pieces to make that part. Okay, same thing here. We have 8 twelfths. So I'm going to break this up by drawing 8, or by drawing 12 and filling 8 in. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think that's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So let me erase those dots really fast. And we need to shade in how many? We need to shade in 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now, this one's hard because we have to have it so it's just 2 shaded in. So if you're going to a smaller number, we can't split it up like this. Because then what do we notice? We've made a number bigger instead of getting it down to 2. So I'm going to draw another model for us. And I'm going to break it up right here. And it's telling me there should only be 2 pieces shaded in. So that would be 2 pieces shaded like this. Because 2 shaded. And now I need to see, am I supposed to break this part up or not? Well, just by looking at it visually, it looks like this size right here is the same as the other. So I think it's 3, because we have 3 total pieces. But let's just check. If I break 2/3 up, so I have 8 pieces, then I should have 12 total. So let's break this up just to check. There's 1, 2, 3, 4, 5, 6, 7, 8 total shaded pieces. So let's check now. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, there's 8 total shaded pieces. And then how many total pieces to make the whole? Well, that would be 9, 10, 11, 12. So yeah, 2/3 is our right answer. Now let's head to the last one on this page. We have 4/5. So 1, 2, 3, 4/5. Shade in 4 of them. And we now need to make it so there's 8 shaded pieces. We have 8 parts. So if I split it in half, we have 1, 2, 3, 4, 5, 6, 7, 8. And then what about these mystery pieces? Well, it's 9, 10 pieces to make a whole. 10 pieces to fill up. So we have 8/10. Let's head to our more difficult problem-solving word problems. Monarch butterflies migrate, meaning they fly to a different spot. When they sense daylight hours are shorter, temperatures get colder, and plant life gets weaker. Write 2 equivalent fractions for the part of the migration a monarch can fly complete in 1 week. Well, here it says it travels 1/5 of the total migration in 1 week. So we want 2 fractions that are equivalent to 1/5. Well, let's start out by drawing a model. So here is 1, 2, 3, 4, and 5. So that last one's really big, so I'm just going to shrink it down. And they can travel 1/5 of a week. So what's an equivalent fraction for that? Well, if I break it like this, then I have 2 pieces out of 10 total. I can also, instead of breaking it like that, I can break it like this and have my imagination on and say that this size is the same as that size, or if it really bothers me, I can redraw it. But I would have 1, 2, 3 parts shaded out of how many? Well, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 3/15 is also the same as well. Some other numbers you could have put, you could have had, if you want to get super fancy, 20 out of 100, because notice what we talked about. If you multiply this by 10, and you multiply the top by 10, those are also going to be equivalent fractions that we'll find out later how that works. Number 18 now. Let me zoom out for us. It says, Garrett buys lunch for himself and his friends. He buys 2 sandwiches. And so then since I see sandwich over here, I'm going to highlight that also. He buys 2 fries. And he buys 2 malts. And if you don't know what a malt is, it's kind of like a chocolate shake, which you see right here. They're giving us that extra word to help out if we weren't sure. How much did Garrett spend on lunch? Use coins and bills to solve. Well, what we have first is we have to figure out the sandwich. So he has 2 groups of 8. So we can do 2 times 2, or we can do 8 plus 8. Either way, we get 16. So we spent $16 on sandwiches. For fries, we have $2.75 times 2 because there's two groups of them, or I could do $2.75 plus $2.75. Either way, you'll notice 275 times 2 is going to give us the same answer. So let's zoom in. I'm going to use multiplication. 2 times 5 is 10, so I regroup that one. 2 times 7 is 14, plus 1 is 15, so I regroup that one. 2 times 2 is 4, plus 1 is 5. And then that decimal, we need to bring it down. So we spent $5.50 on French fries. And our last one is he bought 2 malts. So that's $3.50 plus $3.50. So this one I'm going to add, but I could also do that multiplication if I wanted to, since they're the exact same thing, since multiplication is repeated addition. So we spent $7 on malts. So now we need to add that all up. We spent $16, $5.50, and $7. So 16 plus $7 is $23. And then since I'm adding my French fries, I had to put that decimal in because I have to add the cents with cents and the dollars with dollars. So my final answer, I spent, or I'm sorry, not I did because I'd never spent this much, but Garrett spent $2,850 or $28.50. Now, number 19. Connor, our smart kid, said, to the nearest 100, I've attended school for 800 days of my life. Write 3 numbers that could have been the actual number of days Connor has attended school. Well, we need numbers that when they round to 100, the nearest 100 is going to give us 800. So we can start below 800 or above 800. So let's start with below 800 first. So below 800 be in the 700s. And when we round, remember, we go next door. And for it to round up, remember, it needs to be 5 or more. So we need a number that's 5 or more next to that 7. So let's say 6. And then ones, when we round up, remember, it actually doesn't matter. So we can put whatever number we want. So with that is one answer for us. What could another answer be? Well, 7 and going next door needs to be 5 or more. So let's say 9. And then we could say whatever we want for the ones, since the one's going to turn to a 0 anyways. So that's another one. Now, what if we want it to instead be above, meaning that he's rounding down, but we still get to 800? Well, that means we'd start at 800, and we go next door. For it to round down, it needs to be 4 or less. So we need a number that's 4 or less. So let's pick 4. And remember, the ones doesn't matter, so we can put whatever we want. So all of these numbers will round to 800. If you had any number from 750 all the way to 849, all those numbers will actually round to 800. Now number 20. Josh, Lisa, and Vicky each ate a fourth of their own pizza. Each pizza was the same size, but Josh ate 1 slice, Lisa ate 2 slices, and Vicky ate 3 slices. How is that possible? So let's start. They're telling me there's 3 people, and they each have their own pizza. So I'm going to draw a picture for our pizzas. And they're telling me they each ate a fourth. So let's break this up into fourths. And I guess I'm using the highlighter to break it up into fourths. Now, here's our tricky part. It says each pizza was the same size, but Josh ate 1 slice. So here's Josh. Here will be Lisa then. And here's Vicky. And it says Josh ate 1 slice. So this is what Josh ate. And oh, look, that's still a fourth. It says Lisa ate 2 slices. But if we shade in 2, notice that's now 2 fourths, which is not 1/4. So there's a problem going on here. And if we went to our last one, if we went to Vicky, it says she ate 3 slices. But if she ate 3 slices, that's 3/4, which isn't the same as that 1/4. So there's an issue going on. Oh, it must be, since we're working on equivalent fractions, we should use equivalent fractions. So I'm going to break these all up into equal sizes. Notice I had to draw 2 lines since I'm using the circle, because I need this size to be the same as that size. If I didn't draw 2 lines, I just drew 1, notice how this group right here is much bigger than this group. So remember, when I break it up, I always have to make sure they're the same size. So now let's see. She ate 2 pieces. That'd be 1, 2. And look, it's the same amount as this guy over here that Josh ate. So her fraction must be 2 pieces out of 1, 2, 3, 4, 5, 6, 7, 8. Out of 8 pieces. So maybe that's what happened with Vicky too. So let's break Vicky's up, but instead we want to break 1 piece up into 3 pieces. So there's 1, 1, 2. Oh, so we need to break it up again. 1, 2, 3. Ah, so she ate those 3. And I see these are the same size down here, but notice this one right over here isn't the same. So I have to break that up also into 3 pieces as well. So now let's see. We have 3 pieces that have been eaten out of how many? Well, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, looks kind of like a clock. So that's how it's possible. Josh cut his pizza into 4s, Lisa cut hers into 8s, and Vicky cut hers into 12s. Now for our last one, number 21. Select all the fractions that are equivalent to 2/3. Use the area models to help. So let's see. Here's 1, 2, 2 pieces out of 3. And if we split this like that, oh look, it's still the same. It's whatever this model is. Oh, so these models must be the same. They must be equivalent. So what do I have here? Well, I have 1, 2, 3, 4. 4 pieces out of 5, 6. So 4, 6. Do I see that anywhere? I do. I see it right here. And what about this guy over here? Well, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 pieces out of how many? 9, 10, 11, 12. Hey, it's kind of like our pizza we just did up there with 12s. And I see that right here. None of these other models match. So what do you think? Is that all of our answers? You said yes, you are correct. Now our next one says 22. Select the pairs that are equivalent fractions. Use the area models to help. Now they didn't fill in any of these for us. It's going to be up to us. So let's check here first. 1/4. Can I shade any of these to be 1/4? I can fill this guy in as 1/4. And then if I look over here, well, this doesn't help me. It doesn't look the same. But if I shade in 1 piece over here, I'll notice it doesn't look the same. But if I shade 2 in, it does. And look, this is 8s over here. 8 pieces to make a whole. This one is 4s. And this one is a half. So 2 8s I see is right here. Let's head to our next one now. 3/4. So let me pull, we're going to do blue for this one, 3/4. So that means I would go to my 4ths and I shade in 3 of them. And then over here I would need to shade 1, 2, 3, 4, 5, 6. Oh, and look, that's what it says right here. So those must be equivalent. So remember, whatever I shade on this side, it should be the same like over here. They both kind of look like that Pac-Man. So now let's check our next one, 7 8s and 3/4. Well, here we already have 6 8s shaded in from previously. So if I shade in 7 8s, does that look the same as this right here? No, it doesn't. It has that extra spot that we shade in here. So this one is not equivalent. Now let's look at this next one. This next one I'm going to make it green. So we're going to clear this off. And now what do we have? We have 8 8s, so that means we shade this whole entire thing in. And we have 4 4s, so we shade that whole entire thing in. Does it look like we shade the same amount? If you said yes, you are correct again. And now our last one. It says we have 1/2, so let's check with 1/2, and we'll use black for this one. So here's 1/2. Does 1/2 look the same as if we shaded in 2 halves? Well, hopefully you realize the answer is no, because here we shade in this extra part. So this one is not equivalent either. All right, guys, that is it for the beginning of our fraction unit.